Papa?
Mm.
Okay, so now the next thing is we are going to look at the average kinetic energy. So remember from the basic physics, kinetic energy is equal to half mv square. So here we are using mc square, and remember from what we derive, we have pv is equal to n mc square all over 3. So we can now just say we can add half to both sides of the equation. So therefore we now have pv over 2 is equal to half n mc square times 1 all over 3. So we can now simply say that pv all over 2 is equal to n times mc square all over half times 1 all over 3. So this is kinetic energy. So we now say pv all over 2 is equal to n times kinetic energy times 1 all over 3. So from here, we will now say pv is equal to 2n times kinetic energy times kinetic energy divided by 3. So now from here you can clearly see that pv is directly proportional to kinetic energy. So now from here we know that we can now make kinetic energy subject of the formula. So K is equal to 3 pv all over 2n. So therefore now we have kinetic energy is equal to 3. Remember that pv is equal to RT. So you have pv RT all over 2n, and R all over n naught is known as Boltzmann constant. So therefore you can now remove R over n naught and replace it with Boltzmann constant. Therefore we now end up having kinetic energy is equal to 3 kT all over 2n. So this is the relationship between kinetic energy, Boltzmann constant, and temperature. Then the next thing that we are going to look at is the derivation of total kinetic energy. Okay, so for we to get the total kinetic energy, remember we said we have this. So we can now see kinetic energy is equal to 3RT all over 2n naught. So total kinetic energy is equal to total kinetic energy is equal to kinetic energy times Avogadro's number. This is Avogadro's number. So therefore now to get total kinetic energy, you will now see 3RT all over 2n naught times n naught. So this one will now take care of this. So we now have total kinetic energy as 2R all over 2. Okay, now the next thing is we want to see how we'll drive Charles law from this. So to drive to drive Charles' law, stop it, Charles' law. So to drive Charles' law, we are now going. Remember that we said phi v is equal to 2n times kinetic energy all over 3, and remember that kinetic energy is directly proportional to temperature. So therefore we can simply say phi v is equal to 2n times temperature divided by 3. So we now replace kinetic energy with temperature, since kinetic energy is directly proportional to temperature. So therefore we now have phi is equal to 2n t all over 3v. We now have v is equal to 2n t all over 3 times over phi times p. So we now say all these 2n all over 3p are constant. So therefore we now have v is equal to kt, and remember v all over t is equal to k. This implies Charles' law. Stop it.